Assalamualaikum. Hello everyone.
Hello.
Uh,
Hello.
so before we start our discussion, let's just we do a simple intro ourselves. So my name is Zikri bin Rosli and my meeting number is 205977. Next.
Hello. My name is Muhammad Izzat Najmi bin Wahab and my metric number is 206X70.
Assalamualaikum. My name is Muhammad Nasrul Haq bin Mat Ruzi. My matrix number 205919. Okay.
And my name is Adam Muhammad bin Rizwan Izal and my matrix number is 205418.
So I will present my screen first. So we have given assignment to explain mathematical problem solving related to engineering. So we have to find engineering application using Euler or Runge-Kutta methods. So first I will show the sources we have find that is in a chemical engineering that use Euler methods for ordinary differentiation equations. So the example have been given is the concentration of salt X in a homemade soap maker is given as a function of time by ds over dt is equal to 37.5 minus 3.5x. At the initial time, t equal 0, the salt concentration in the tank is 50 gram per liter. Using Euler method and a step size of h equal to 1.5 minute. What is the salt concentration after 3 minutes? So I will show my what I have do for the report. So this is my introduction. First of all, I in my first paragraph, I show what is the meaning of numerical method and what is the meaning of analytical solutions. What is the difference between both? Also, I say that analytical solution are exact solution that are based on mathematical concept, while analytical solution to a mathematical specified issue is conceivable by time consuming. What do you guys think? Is it okay if I put for the first paragraph for introduction that I put is the meaning of numerical method and analytical solution?
I think you can put it on the first graph because it will explain how the numerical method solution and how the analytical method solution both are different, both have different ends. And if I'm not mistaken, the answer nearly same.
Yeah.
But exactly the same. So I think you can put the introduction and analytical methods.
For the second paragraph, I talk about numerical method for ordinary differential equation, ODEs. This I say why the mathematical models in many fields of science, engineering, and economics. This method have many use in engineering in the mathematical models. Also, I state that we use Euler methods for the problem that we find. In this report, we use chemical engineering as an example of how Euler's method might be used in engineering field. Also, I state that from this, we can determine the salt concentration in the tank every second or minute. Do you agree, guys?
Yes, I agree.
So,
Yes.
wait, what? I have a problem with my word. Do you guys see there's something happen? Can we just move to the next presenter first?
Yes.
Yes, I think
All right. I
we
will
can move on to
when
the next presenter.
when my word is okay, I will show my conclusion.
I will present my part, which is engineering problem that we study. So let's see the. You guys see the screen?
Yes, yes.
Yes, yes.
Yes.
For my part, I will part of the engineering application that we to research about this topic. So our group will cover the topic that related to the chemical engineering calculation. Okay, based on our study, this calculation related to the Euler methods for ordinary differential equation. For the main purpose of this case, I think is that Zikri mentioned before this. The example of this case is to find the salt concentration with respect to time, which that state on the equation. Okay, the example case that Zikri mentioned before is the same that I will present. The concentration of the salt in a homemade soap maker is given as a function of time by the equation that given ds over dt equation equal to 37.5 minus 3.5 x. Okay, this example state the initial time t equal to 0. The salt concentration in the tank is 50 gram per liter. Okay, by this example of this case, we can use the Euler's method and a step size of h equal to 1.5 minute. Okay, this case is only to find the salt concentration after the 3 minute. Okay, by this question, we can use the Euler method formula to create a solution of this case. Okay, the second part is about the Euler method step that I want to explain a bit. Uh, okay, from our previous study, we know that the basic idea behind the slope field, directional fields, is to find the numerical approximation to a solution of differential equation. The Euler's method is just another technique used to analyze a differential equation, which use the idea of local linearity or linear approximation, where we use a small tangent lines of a short distance to approximate the solution to an initial value problem. This is an example of the diagram of Euler's approximation. So you guys, how about you guys? Is okay?
I think it's okay. How about we to the next presenter to talk about the body of content? Adam, I
So
think.
we'll continue.
I will stop the sharing. You.
So I will show you the solution for this problem that is related to Euler's method. So we already got the equation, which is dx over dt equal to 37.5 minus 3.5x. So by using Euler's method, we change it into f dx equal to 37.5 minus 3.5x. So by using this literal equation, which is and we input the I, TO, and also x0, which is 50, we can get the approximate amount of x1. So by putting the value, which is 50 plus f in a bracket 0.5 times 0.5, we put this equation by getting from this, which is 37.5 minus 3.5 times 50. So we can get the value of negative 18.75 gram per liter. This is by using the step of 0.5. So we can continue with using the step by adding the time and h, which is 0 plus 0.5, which is equally to 1. So this is T1. So we continue by changing the value of x that is obtained from the first equation. So we can also obtain the value of x2 and also x3 and some more until the third minute. So for the analytical equation solution or the exact solution, which is we need to integrate the equation that is given, which is the 37.5 minus 30.5x. So by integrate it, we can, with all this formula and equation, we can get the final equation, which is 39.286 exponent with a power of negative 3.5t plus 10.714. So by having this formula or value, we can input the value of t to have the exact value at the certain time. For example, we can have the value of x when t is equal to 1 or t equal to 3. So by having this value, I have made a table for the Euler value with the step of 0.5 until the 3 minute. So this is all the value, which is from 0 until the third minute, and this is the exact value from 0 minute to 3 minute, and this is the value of it. So I will, the next presenter will continue presenting.
Okay, Adam, can you help me share the screen because my internet connection is not stable enough. So,
Can you see this?
Yes.
okay, thank you. Okay, so next for the comparison for both solutions, analytical and also for the what the other one?
Euler.
Analytical and numerical analytical. So for the exact value and the Euler method. Okay, so we saw that from the graph we know that the Euler's methods, the end of the graph at 3 minutes, the graph is above the exact value. So from for the error also, there's graph show that the error is that pattern. So from the calculation, exact value minus Euler, and we get the error. So and also we did the graph at step 1.5, but it's not finished yet. So it's still in progress. So the graph shows the two graph shows there is for step 0.5 and also the graph for the error. Okay, I think there's I think that's enough for the comparison. Uh, comparison between two solution and also the error of the two solution. Basically,
May I continue with my report for conclusion? All right. Do you guys see for the conclusion?
Yes, we can see it.
This in the conclusion, I say when we use what when we use the graph comparing the analytical and numerical answer, we can know we can know the what we say that the accurate of the numerical answer that we use that we get. So to change the solution, we should decreasing the step size h in the calculation and comparison. Like we saw that EZ say uh, 0.5 step actually still have a many error, but we will try to do a 1.5 step. We will see if it increasing the error or decreasing the error. By that we can know if we decreasing the step size h, we will get the accuracy or not. Do you guys think the we when we decreasing the step size h will decrease the will increase the accuracy? Guys, you guys think?
Yeah, I think it is true because when the step is has a lower number, it become the error might be dropped than increasing because the error will be the Euler's method will be like the exact value of it of the value from the calculation. So by decreasing the step, we can see that the error might be dropped or might be slightly increased from the our calculation.
For the second paragraph, I said about Ilus method and the fifth Ruger-Kutta method a bit. So I think that's all from us. Do you guys have any to say?
I think I don't have anything to add because I think that's good enough for our discussion or guest report.
All right. I think that's all. Thank you very much for hearing.
Thank you.
Thank you.
Thank you.